Alright, what's up? What's up? So in this video, we're going to be going over the experimental setup, which I've created here to replicate some old Tesla experiments back from the 1890s. But I guess before we get started, I just wanted to say a little bit about what we're going to be doing on this channel and kind of what the whole point of this is. So pretty much, I'm an electrical researcher who a couple years ago became pretty interested in the works of Nikola Tesla. I was trying to understand what electricity was, or like the nature of electricity. And it seems like Tesla was one of the scientists who pretty much took this to the furthest extent and developed the most mature ideas about these. Unfortunately, nowadays, though, when you try to do some online searches for Nikola Tesla's inventions or ideas about electricity or just about the universe in general, you get a lot of stuff that is, it cannot really be attributed to Tesla. So on this channel, we're going to kind of try to cut through all the nonsense stuff and just get to the actual Tesla experiments and kind of try to go step by step through his progression as laid out in some of his old experimental lectures that he gave, and any sort of papers that he may have published. And we're just going to try to replicate a lot of the original Tesla experiments exactly as described by him, and see if we can kind of come to some sort of understanding as to what he actually thought with regards to like what is electricity. So at least towards the beginning of this channel, this book here is pretty much going to be the sole reference material for what we're going to be doing. It's just the inventions, researches, and writings of Nikola Tesla. And what it is, it's just a lot of different, maybe like patents or little write-ups done by Tesla, which outline some new inventions or experimental demonstrations performed by him. He also has some things which go over some maybe theoretical speculations that he has. And you could kind of get some sort of sense as to how he was thinking about the phenomena of electricity. What we're mostly going to be interested in is, starting on page 145, we have some lectures that he gave to different groups. So he has 3 lectures in here. One is in 1891, the next one is in 1892, and the one after that is in 1893. And basically what these are is he kind of gets up on stage and is talking to a large audience, and he'll go over some of his ideas as to, honestly, he'll go over like the ideas pertaining to just the nature of the universe, and then some speculations with regards to what electricity is, the nature of electricity. And then he does a whole lot of experimental demonstrations up on stage, which kind of go over the experiments that he's done to arrive at his conclusions or to support kind of his ideas about these things. So it's these experiments that we're going to try to be replicating here on this channel. So in the first lecture, in the 1891 lecture, Tesla uses 2 different methods to generate his high potential, high frequency currents that he uses for his demonstrations. Towards the beginning of the lecture, what he really focuses on are these high frequency alternators with hundreds of different pole projections on them to generate, however many different alternations per revolution of the alternator. And because today these machines aren't really readily available, or if you really wanted to make one, it would have to be a really expensive custom job. We're only going to focus on the experiments that use the capacitive discharge as the source for high potential, high frequency currents. So that's kind of more towards the second half of the first lecture. And then these same methods will be used for the second and third lectures as well, largely. Here I just have a little schematic showing what what the setup is going to look like. So we just have our input power from the wall over here, and it goes into a neon sign transformer. Then I just have a spark gap thrown across the line here, and a variable capacitor bank, which is in series with this high frequency or high voltage transformer. And we're going to go over that right now. So for every one of these experiments, we're going to need some sort of source of high voltage. So here I just have the schematic for the power supply that I'm using. We're making use of a neon sign transformer to get our high voltage from the wall voltage of 120 volts. And here's just some supporting stuff just for safety and usability. So here I just break out the line into two branches. I just have a 20 amp breaker going to the circuit that's going to be going to our high voltage transformer. And here I just have a 6 amp breaker that just goes to an outlet. And this is not necessary for any of the experiments. I just usually when I build these sorts of power supplies, I like to give myself an outlet in case I need to run any like fans or lights or something, just to have it there. It's just kind of nice. So we go from the 20 amp breaker, and I just have a little on-off switch, like a little wall light switch, just to activate power to the circuit. It goes into an EMI filter. So this is because when you're working with these pulsed power systems, like we're doing with this capacitive discharge system, the current rushes can produce some like EMF back waves that go into your line, like into your house wall supply, and you kind of want to avoid shooting any currents into your actual house supply. So we just put this on here just to try to dampen out any sort of current injections or oscillations that'll make its way back into your house supply. So it's not like a necessary thing for the circuit to operate, but it's just a safety thing that's just good to have there. And from there we go into this variac. So what this is it's just a way to turn or to control the input power to your circuit. So it'll attenuate the signal depending on how you turn a knob, and all this stuff we'll look at later. But then out of the variac, we just go right into our neon sign transformer. So this here is the whole setup. The thing that I just showed on the whiteboard up here, that was just the power supply. So that actually just applies from here back. So pretty much everything that's mounted to this board here is what I was just showing on the whiteboard. So basically what it is I just have this plug here. So that it's just a normal plug. It goes into the wall. And then I break that out. So I have my line here going to these breakers here. So this is the 20 amp breaker. So you can see this is the circuit that's going to be going to our neon sign transformer. That just goes through here and it passes through the switch. So when the switch is here, there's no power or there's no circuit that is actually connected for this high voltage circuit. But as soon as we flip it, we'll get this LED to turn on, and then we have power activated now to our high voltage circuit. That just goes here to this EMI filter, and then the EMI filter goes directly into our variac. And basically the way this works is you turn the knob here and you'll get more or less voltage depending on how you turn it. And out of the variac, we just go right into this little block here where I've mounted the neon sign transformer. And then I also have, I put the ground line here on this block and connected everything together. So everything that requires a ground connection, we can just mount to this terminal block here, like the EMI filter does and the neon sign transformer. So this terminal block just kind of makes it nice and easy to make all those connections. This here is the 6 amp breaker that just goes to these outlets. So if you just need to plug anything in for any upcoming experiments, now we have those ready to go. So it's just nice and convenient. And I guess we could turn it on real quick and just show you what it does. Okay, so for this part, I've just kind of disconnected the rest of the circuit from the power supply. So normally, when you would operate it, we would have these plugs just going into the power supply here. But I just took those out and just put these little alligator clips in there for the meantime, just to test the power supply. And I put these bolts in between them. So we got a little bit of a gap across our high voltage output. And when we turn this knob up to a certain amount, we should see a little flame or some sparks shoot across there. And that way we'll know it's working. So I'm just gonna start dialing it up a little bit. I've already, I left the power on. So we're just gonna start turning it up. And you can start to hear a little bit of hum from the transformer. And go up more. There we go. We'll get a little better look at that, just because it's cool. There you go. So looks like everything's working over here. So I've connected the circuit back up to the power supply just like normal. We have these two inductors on either side of the high voltage transformer. And that's because when this thing is operating and we're sending these big current impulses whenever the spark gap breaks, we don't want to send any current back into the transformer. We want all of our impulse currents to stay within our resonant circuit, or the resonant side of the circuit. So we can think of this as like our input side, and this is our resonating side. And we kind of want to isolate these two as much as we can from each other. Because if you start sending all these large current impulses back into your high voltage transformer, it's going to break it pretty quick. So I just put this here just to protect it, and to try to create a very high impedance for any currents that want to go back in towards the transformer. Whereas here it's a much lower impedance path, and it's going to mostly stay here when it's oscillating. So this here is the spark gap that I'm using. I've used this kind of design in other circuits before, and it always seems to do a pretty good job, and it's pretty easy to adjust. So I went ahead and just put it down on this circuit here. What it is it's just little copper tube sections, and there's a hole that I drilled in the middle of each of them, and I run a bolt through it to just secure it to the wood here. And then I just throw a little insulator around it just to support it and kind of get it up off the wood a little bit. And this is pretty nice because it allows you to adjust it pretty easily. So you would adjust the spark gap to increase the voltage that is built up on the capacitors before each discharge. So pretty much when your spark gap is small, once you get just a little bit of voltage across these capacitors, it's going to break, and then you're going to have to start recharging your capacitors over again. But if you have a really large spark gap, you'll have to store quite a bit of charge in your capacitors before the spark gap breaks, and you get really big current inrushes into your system. So it's kind of nice to have a spark gap that's adjustable, so you can kind of play with that as you're doing your different experiments. So with this one, the way you would adjust it is, because there's only one point of contact, when you mount these, it's just easy to turn them. So you can see right now we have that much, we have just a little bit of space in between each of these tube sections. But if I take this and I turn it a little bit, now we got much bigger gaps between each tube. And this right here would produce some really big current inrushes. But it's just that easy just to tune this one. So it's something that I like to use for my circuits. And it's helpful when you do this to get like a stack of poker cards or something, and make sure that these copper tube sections are parallel with each other. So you get kind of even breaking. Basically what we're looking for with this is we want kind of even breaking all along the length of the pipes. If you have, you know, if you set it up like that and you try to run it, even though you have a large gap right here, you know, you got a tiny little gap right here on the point of the tube, and it's just you're just gonna get weak little effects. But if you keep it parallel, you're gonna get the best performance. So that's just something to keep in mind when you're running it like this. Here we have the capacitor bank. So this is a adjustable capacitor bank. All it really is I just have these WEMA high voltage capacitors. So these are 6,000 volt capacitors, each of them. And I placed 3 of these in series with each other. So that's 18,000 volts total. And the way it kind of works is I have this little wire here, which connects to these different bolts. And if you want to increase or decrease the capacitance, you would just connect or disconnect different capacitors to the bolts here. So everything that you connect to these bolts, it just basically puts it in parallel with each other. And as you add more capacitors in parallel, you're going to increase your capacitance. I kind of just built this one recently, so I'm kind of trying it out for the first time. So you'll notice not all of these are even wired up yet. I've just wired a couple, and I'm just kind of been experimenting with it for today. Seems to be working pretty good so far. I don't know why I decided to run it like this, where I have to tighten everything with nuts and bolts, and I didn't just use switches. It was kind of one of those things where I was building it, and then like halfway through I was like, but anyway, we're just going to run with this for now, and possibly later we'll do an upgrade to make it easier to use, because having to like unscrew this and put the connector on and screw it back in every time you want to make little adjustments, it's pretty tough when you're trying to, you know, fine tune your circuit. So it'd be nice if I just had something with like switches that I could switch capacitors in and out really quick. So that'll probably be a future upgrade here in a little bit. But for now, that's what we got. And this is the high voltage transformer. So I'll probably do another video just on the design of this a little later, but this is taken out of a design that Tesla gives in his 1892 lecture, and he kind of hints at in his 1891 lecture. And it was built as accurately as possible to what he was describing. So pretty much we have our primary input here, and I'll do another video where I break it down, like what all is going on in here. But pretty much this is just a primary connection, even though it looks a little complicated. And this is our high voltage output here across these two. All right, and that's pretty much the basic overview of what we got going on here. So it's really nothing too complicated. Maybe I'll go in later and kind of clean up this wiring and stuff, because it's a little messy, but it'll work for now. So I'll just kind of show you how to turn it on and fire it up and make sure it's working. Because it is a little bit late right now and the spark gaps can get kind of loud, I did go ahead and tune it down to like the smallest possible gap that we can do and still get it to work. So we're not going to be getting any sort of powerful effects or anything, but it's going to be quiet. And that's just because I'm literally doing this in my bedroom in my apartment. So, you know, it's all good. We're going to turn it on now. We'll do a switch. And now we have power going into the high voltage transformer part of the circuit. So as soon as we start to turn this knob, we'll start to put some voltage across these capacitors and across the spark gap. And once the capacitors are charged a certain amount and the potential reaches a certain amount, we'll get a break across the gap, and you'll be able to see it in here. And once we start putting currents through this primary side of the circuit, we'll be able to see that we're getting high voltage out of the secondary side. So I'm just going to turn it up a little bit. And because our gap is so small, I'll just need to turn this up just barely, and we'll start breaking our spark gap. I'm just going to, here, I'll get this view. So we're at 0 volts right now. I'm going to start turning it up. That's all we need. So see, the gap is so small, all I did is this. But there we go. We are getting some breaks here. So every time it breaks, that is sending a current impulse into this primary side of the circuit. And with the inductance of the primary and the capacitance here, it's gonna oscillate for a little bit as it dies out. So each time that we see a little spark break across that gap, we're gonna get some sort of waveform that looks like this. So that's the waveform that we're injecting into our primary circuit. And that's what's getting transformed by the secondary part of the high voltage transformer. And we can basically adjust the capacitance to affect the frequency of that modulated pulse. So we're going to turn it on again, and now we're just going to look at the output part. Again, I'll just barely turn it up. There we go. And I got my little rod here. So we should be able to put this thing up next to the secondary and just see some sparks. There we go. And again, everything about this right now is as low power and as weak as we could possibly get it. Just because it's late. I'm not trying to make too much noise. But we can turn up a little bit. So when I turn up the knob here, when I turn up this knob here, it's going to increase the input voltage that goes across these capacitors, and it's going to basically charge them up quicker. So we would expect to get faster braking across the spark gap. And you'll be able to see it and hear it too. But we'll start off, it's really small. And now we're just going to start bringing up the input voltage a little bit. And remember what I was saying earlier, how if you don't adjust them carefully and get them parallel, you won't get very good braking. I can see, just because of the way that this top one is braking, that these first two tubes are not parallel with each other. So if we were to turn this one that way a little bit, it would be better. But this is good enough for now. I'll just keep turning it up. Okay. We should see a little more output here. All right. That's basically it. So looks like it's working. I'll do some videos later where I, crank it a little more. But that's the basic experimental setup here that we're working with. And I'll remember to do the video too on that transformer construction.